And here comes the truth table for this function. Look at the composite sentence. This composite proposition can be true if 1. It is true that she has married him and they are honeymooning in HL now. Or 2. It is false that she has married him and it is also false that they are honeymooning in HL now. If it is true that she has married him but it is false that they are honeymooning in HL now, then the proposition is false because P does not imply Q. The last case is when she has not married him but they are honeymooning in HL now, which is found by most people to be paradoxical. And here comes the truth table for this function. And finally, the fifth type is equivalence. The logical connective symbolized by the double bar expresses the meaning of if and only if in English. When we connect two propositions using this symbol, we form what's called a biconditional. For instance, the sentence John is married to Mary if and only if Mary is married to John can be represented symbolically as J marries M, M marries J. This means the truth of one depends entirely on the truth of the other. They must both be true or both be false. The biconditional connective is appropriately named because it's actually a combination of two conditionals, one going in each direction. In other words, there's a general rule that says PQ is logically equivalent to P implies Q and Q implies P. Or written symbolically, PQ is the same as P, Q, and P's. QEP. This means both statements must imply each other for the biconditional to hold true. The symbol tilde, written as AEs, is used in propositional logic to mean not in English. Unlike connectives such as and or, which join two propositions, the tilde doesn't connect anything. It's simply prefixed to a single proposition to indicate its negation. That's why it's more accurate to call it a negation operator, rather than a connective. For example, Alice didn't sleep would be represented as asleep. Claire is not married to Bill becomes Mary be. In both cases we're applying the negation operator to the original proposition. And here comes the truth table for this function. When reviewing this content, learners need to master the concept of truth functionality. The principle that the true-false value of a complex sentence is determined based on the true-false values of its component clauses and the logical connections between them. Review common connections such as and, or, if, then, not, and understand the corresponding truth tables. Learners should practice determining the truth value of sentences by analyzing the logical structure, especially conditional and negative sentences. Doing exercises with truth tables will help consolidate knowledge in an intuitive and accurate way. That is the end of the lesson and also the course. Thank you very much for your attention.